Those of you in the audience might say that you are all sitting still while I am moving up here. But as far as I'm concerned, we're all moving. This stage is moving, the chairs are moving, this building is moving, because the ground we're standing on is moving. A quick Geology 101 lesson. The Earth is made up of 3 layers: the crust, the mantle, and the core. But actually, the crust is part of a top rigid layer that moves as a unit, and below that, within the mantle, is a weak layer that flows. I am interested in how mantle movement affects the surface of the Earth. More specifically, how those top 2 layers interact with each other. Which one causes the other to move? Now, about 2 years ago, this wouldn't even be a question, because for the past 40 years, we've thought that we knew what this relationship was. The top rigid layer is very heavy on one side and sinks, dragging that weak layer along. However, there have been some recent observations of flow in that weak layer that cannot be explained by this model. Therefore, it needs some improvement. I seek to understand the relationship between these 2 layers through running a 3-dimensional spherical computer model with a realistic viscosity in that weak layer. That is, shear in that layer causes it to become less viscous or less thick. This is a unique approach, as previous studies have simplified their models by using a singular value for viscosity, or using a 2D model, or using a rectangular geometry. Using this more realistic spherical model, I've discovered something very surprising. The weak layer actually moves by its own power and pushes the top layer forward. Furthermore, the weak layer moves faster than that rigid layer. I also discovered that with this change, the mantle itself moves up, also moves down. The distance between those things has become very great. Possibly most significantly, the direction of flow in that weak layer actually rotates with depth, which matches those observations the previous model could not explain. This is a paradigm shift in my field. It completely changes the way that we think about crustal movement. Although the crust only moves about 1 inch a year, the rate it takes your fingernail to grow, the movements can be monumental, building mountain ranges and changing ocean currents, and further, very important effects.